Hello students, today we will discuss some important why question, reasoning question in the chapter alcohol, phenol and ether. In the last class, we have discussed some why question of haloalkane, haloarine. When you are writing the answer of some reasoning question or why question, you have to write the correct answer to the point. Don't explain, don't elaborate more. Only briefly one more question means one, two sentences you will write. Don't write more. So some important question about alcohol, phenol, ether, let us discuss. Aromatic ether cannot produce PHI by the action of HI. That means haloarine cannot be prepared because here what happens? I minus cannot attack AR. I minus cannot attack AR and rather it produce what? I minus attack to R forming RID, then phenol. Because aromatic ether here this RO bond is a double bond character, cannot be hydrolyzed by I minus, cannot be substituted by I minus because due to double bond character. This is the answer. Then question number 14. ROH acts as better nucleophile. Why ROH acts as better nucleophile? Because ROH, due to plus I effect of R, electron density of oxygen is more. Due to plus I effect of R, electron density of oxygen is more. That's why it acts as better nucleophile. Okay? I am repeating again. So here, due to plus I effect of R, electron density of oxygen is more. You have to draw the structure. Then oxygen is more electron density. That's why it acts as a better nucleophile. 13. Phenol is an weak acid. Why phenol is an weak acid? Because phenol, what happens? When phenol is presence of water produce equilibrium between phenolate ion and hydronium ion. But this process is reversible. As it is a reverse, because it is a weak acid, as it is a reverse process, so phenolate ion is not completely losing H plus ion. That's why the process is reversible. As a reversible process and the process is very slow process, that's why phenolate ion not completely losing H plus ion. That's why it is weak acid maintaining equilibrium with its phenolate ion and phenol. That's why it is a weak acid, not completely losing H plus. Then question number 12. Phenol is more acidic than ROH because if you see the structure and phenol produce phenolate ion and alcohol produce RO minus, and this here conjugate base is phenolate ion, its conjugate base is RO minus. If you see the stability, it is more stable by resonance. More stable by resonance, that's why it is more stable. It is more stable. Phenolate ion is more stable than alkoxide ion. That's why phenol is more acidic than alcohol. This is very important thing. Then question number 11. Haloarine is not used in the preparation of ether by Williamson synthesis. Already we discussed this thing. In case of haloarine, what happens? Haloarine has resonance. Haloarine has resonance. Due to resonance, it gets double bond character. When it gets double bond character, as it gets double bond character, the X become double bond with benzene ring. That's why it cannot be substituted by what? Base. When a nucleophile reacts with the air, because nucleophile cannot, your answer is like this, as nucleophile cannot easily substituted in haloarine due to double bond nature of halogen with benzene ring. That's why it does not show nucleophilic substitution action easily. Clear? Then question number 10. Higher ether are water insoluble because higher ether, because the R group is generally hydrophobic nature. That's why higher alcohols are less polar and it is not soluble in water due to hydrophobic and R group. That's why it is water insoluble. Alcohol has higher boiling point than ether because alcohol has stronger hydrogen bonding. Delta minus, delta plus attack to OHR, delta minus, delta plus. Due to stronger intermolecular hydrogen bond in alcohol, it has higher boiling point compared to ether. Alcohol has stronger intermolecular hydrogen bond than ether. That's why boiling point of alcohol is more. Then question 8. Sodium metal can be used for drying, ether not alcohol, because ether has no replaceable hydrogen. This is the answer. Ether has no replaceable hydrogen. That means it cannot produce H plus. That's why sodium metal cannot react with ether. That's why ether can be dried with sodium metal, but it cannot dry alcohol because alcohol has replaceable hydrogen. That's why it reacts with sodium metal. That's why we cannot dry alcohol using sodium metal. Then primary haloalkane is more preferable for Williamson synthesis because primary haloalkane produce easily show nucleophile substitution reaction. If we use secondary and tertiary, it shows elimination reaction. That's why Williamson synthesis generally alkoxide ion acts as better. In case of secondary and tertiary, alkoxide ion acts as base. So if you use secondary and tertiary, you get alkene instead of haloalkane. That's why Rx is more preferable for Williamson synthesis. If you use secondary and tertiary haloalkane, then you will get alkene. That's why primary haloalkane is better reagent for preparation of ether by Williamson synthesis, because secondary tertiary haloalkane gives alkene instead of nuclear substitution reaction, they give elimination reaction. That's this is the answer. Tertiary alcohol is more reactive than secondary tertiary because tertiary alcohol more reactive. First is tertiary alcohol has more cross effect. If you see the structure of tertiary alcohol, as it has more cross effect, so CO bond is more polar. This is the first answer. Second answer, this tertiary alcohol produce tertiary carbocation which is more stable, so easily shows nucleophile substitution reaction. Alcohol shows better nucleophile substitution reaction because tertiary alcohol produces tertiary carbocation which is more stable. Two types of answer you can write. First answer, due to more close effect of methyl group, CO bond is more polar, CO bond can easily replaced by nucleophile. Second answer you can write, tertiary alcohol produce tertiary carbocation which is more stable compared to secondary and primary. So this is the answer. Both answers is correct. Better you write two answer. Point wise. Question number 5. Tertiary alcohol is less acidic than secondary and primary because it has a cross effect. As it has more cross effect, H plus cannot easily release from oxygen due to increasing more electron density by methyl group cross effect taking methyl group. Methyl group has more cross effect, it increases electron density towards oxygen. That's why H plus cannot easily produced from oxygen of alcohol. That's why the acidic character is less because more cross effect. Then question number 4. Phenoxide ion, not phenol, is treated with carbon dioxide in Coles reaction. In Coles synthesis, if you write this one, phenoxide ion, not phenol, is treated with carbon dioxide because here what happens. If you use phenoxide ion, what happens? Phenoxide ion has negative charge on oxygen. Due to the negative charge on oxygen, what happens? This phenoxide ion donates electron towards the benzene. That means it easily plus M factor favor. In case of phenoxide ion, plus M factor is more favorable than phenol. if you see the structure of phenol and your phenoxide ion prefer more because the plus M effect of phenoxide ion is better than the phenol. That's why, because oxygen carry more negative charge, the transfer of electron towards benzene is faster. That's why phenoxide ion facilitated it helps to increase the electron density in the benzene. That's why carbon dioxide acts as electrophile, easily attract to benzene. Only answer is phenoxide ion. Oxygen carry more negative charge, which facilitate the formation of double bond towards the benzene due to more electronegative charge. That's why plus M effect is more favorable than plus M effect of phenol. That's why it favor the faster the formation of electrophilic substitution reaction of attacking of carbon dioxide. Lower alcohol are water insoluble because lower alcohol produce stronger hydrogen bonding due to more polar character. Because higher alcohol has greater R group, which is a hydrophobic nature. That's why it hinders the formation of hydrogen bonding. So lower alcohol produce stronger hydrogen bonding compared to higher alcohol, because higher alcohol, the alkyl group is generally hydrophobic nature. It opposes, it is less soluble in water. This is the answer. Lower alcohol are more soluble because it produce better hydrogen bonding compared to higher alcohol due to hydrophobic alkyl group. Orthonitrophenol has lower boiling point than para-nitrophenol because orthonitrophenol, if you draw the structure, it has what happens? Intramolecular hydrogen bonding. In orthonitrophenol, it has intramolecular hydrogen bonding. That's why the boiling point of orthonitrophenol is low. But in case of para-nitrophenol, the intermolecular hydrogen bonding takes place. Due to stronger intermolecular hydrogen bonding of para-nitrophenol, boiling point is more. But in orthonitrophenol, due to intramolecular hydrogen bonding, the bonding becomes weak between the orthonitrophenol. That's why orthonitrophenol is more volatile. Also write another question, very important. Orthonitrophenols are more volatile than para-nitrophenols. Orthoisomer is more volatile than para-isomer. This is very important. This is the same question and same answer. Orthoisomer is more volatile than para because due to intramolecular hydrogen. That's why the interaction is low. That's why boiling point is less. This is about this second question. First question, phenol is not easily protonated because we know phenol has resonance. As phenol has resonance, you draw the structure of phenol. You try to draw the structure of phenol. As phenol has resonance, already know it has lone pair on the oxygen atom. Due to resonance, then what happens? The electron density in oxygen decreases. As electron density oxygen decreases, that's why OH group cannot easily protonated. But if you see alcohol, due to the plus effect of alcohol, plus effect of R, the electron density oxygen increasing compared to phenol OH group and alcohol OH group. The electron density oxygen of alcohol is more. That's why alcohol can easily protonated, but phenol cannot be easily proton because due to resonance, electron density oxygen decreases. So OH group cannot accept H plus easily because electron density is low due to resonance. That's why cannot be easily protonated. So these are some important questions of alcohol phenol ether. Try to understand the question fast. When we are reading the question, carefully read the question, try to understand the question, what is asked, And when you are writing the answer, don't write more, you write briefly to the point you write. Whenever the structure is required, also draw the structure clearly. Then whenever resonance structure or hyperconjugation structure or inductive structure, if anything is required, you show with explanation, you show the structure so that it will give a good impression to the examiner, so that they will give exact mark, actual mark to the question. And so this is about the why question. You practice more, any doubt you can ask me. Okay, thank you all.